In this video, I'm going to do some examples of multiplying polynomials. I'm going to look at monomials, binomials, trinomials, some different things, and talk about some different ways you can keep your work organized. A lot of doing this kind of math by hand is about knowing what you need to keep yourself organized so you don't miss a piece. So I'm going to show you two main strategies, and you're going to kind of have to decide which strategy makes sense for you to use for any given problem. And I'll talk a little bit about how I make that decision for me. But what's important is that you keep things organized in a way where you don't lose track of pieces of your work. So the simplest kind of situation we're going to look at is as if I have a monomial, something like 3x multiplied by, I don't know, a binomial, a trinomial, something like that. So maybe I have it multiplied by x minus 7. So this is a multiplication problem, and I need to distribute it to each thing in the parentheses. Order of operations is I have to do the stuff in the parentheses first, but there's nothing I can do here. I don't know what x is, so I can't do anything in here. Instead, I can rewrite this and distribute this to each term in here. So I might do that using just the distributive property and some arrows. 3x times x would be 3x squared, and 3x times negative 7, 3 times 7 is 21, so I'd have negative 21x. So I might just be able to do it that way. Just go, well, I just distribute it, maybe I use some arrows, and I do those multiplications. I might also want to use an area model. One way to think of multiplication is to think about how if I have a rectangle, the side lengths of that rectangle multiply together to make the area of that rectangle. So if I think of myself as having a rectangle with a side length of 3x here, and a side length of x minus 7 here, then the area of this rectangle is the same as the answer to this multiplication problem. And I can break it in to some smaller rectangles. I break it up at the terms. So since this has two terms, I break it into x and minus 7, because those are my terms. So now I have two rectangles. I have this one that has dimensions of 3x times x, which would be 3x squared, and this one that has dimensions of 3x and negative 7, which would be negative 21x. And so this is another way to keep my work organized. And this may feel a little bit like overkill here. I wouldn't use this method for this problem personally, but I would as the problems get more complicated. So let's look at multiplying a binomial by another binomial now. If I have, I'm going to do x minus 7 again. It seems fun. X minus 7 times 4x plus 3. So I could use that same distributive property method. Again, there's nothing I can do in either of these parentheses. There's no like terms to combine. I can't do anything. I'm stuck. So what I can do is I can multiply these by each other. I need to multiply each term in the first parentheses by each term in the second parentheses. So I can do that just with arrows like this. X times 4x would be 4x squared. X times 3 would be 3x. And now I've considered the first term in here by each of the terms in here. I still need to consider the second term. So I look at my negative 7. Negative 7 times 4x. 4 times 7 is 28, so that would be negative 28x. And last but certainly not least, negative 7 times positive 3. 7 times 3 is 21, so I'd have negative 21. So I've multiplied each thing here by something in the other, each thing here by each thing in here. So I end up with 4 terms. And when I look at them, two of these happen to be like terms. That will often be the case, depending on whether you have binomials that were of the same degree to start with. And so I can simplify this a little bit by combining my like terms. I'd get 4x squared. 3 take away 28 would be negative 25x minus 21. But this is where that generic rectangle method starts to be a little more useful, is when they're this big. Let's look at what that'll look like here. So I've got my generic rectangle here. I'll put x minus 7 along this side, 4x plus 3 along this side. Again, I broke this up at the terms. So now I've got a spot for each of my 4 answers, so I'm more likely to remember to do each of them. I have x times 4x, and that gives me 4x squared. I have x times 3, and that gives me 3x. I have negative 7 times 4x, and that gives me negative 28x. And I have negative 7 times positive 3, and that gives me negative 21. So the advantage here is that I can very easily see if I forgot to do one of these because there'd be an empty box. And then again, I would need to combine my like terms and write it out. When I'm doing this, I'll often put a little check mark as I get to each term. So I'll write 4x squared, check mark. These are both x terms, so that ends up being negative 25x. I'll put little check marks there. And negative 21. And that way I know that I've touched all the boxes. So this is where this method starts to come into its own, and where I find it useful, even for somebody who's practiced this quite a bit, is if we start getting into like multiplying a binomial by a trinomial or a trinomial by a trinomial. As it gets bigger and bigger, I need some sort of chart to keep myself organized. So let's do a binomial by a trinomial so that you can see that too. So if I have 2x plus 1, that plus sign a little clearer, and I want to multiply that by 5x squared minus x plus 2. Now I'm going to start having some organizational challenges, just keeping track of what I've done or not done. So I'm going to do my best, but this is where I know I need to start paying attention because there's just a lot to do. I have to take that 2x and multiply it by the 5x squared. 2 times 5 is 10. X times x squared is x to the third. Now I have to take that 2x and multiply it by negative x. So that'll be negative 2x times x is x squared. And I'm not even done with my first term from here yet, because now to do 2x times 2. 2 times 2 is 4, so that's 4x. And now I've resolved the things from the first one. So now I can tackle the bottom. I call it the bottom because that's where I put the other half of my arrows. I could put all the arrows at the top, but I just find that gets messy. That's another reason this gets tricky when there's more than 2 things here, is because then I'm going to have to share either putting 2 of them on the top or 2 of them on the bottom. Good news, 1 is an easy number to multiply by. 1 times 5x squared is going to be 5x squared. So all of these are going to be computationally not very challenging, and that's kind of the gift that 1 gives us. 1 times negative x is negative x. And 1 times 2 is 2. So now I have 6 terms. To figure out how many terms you're going to have before you start simplifying, you would take the number of terms here and multiply it by the number of terms here. So since there's 2 terms here and 3 terms here, I know there will be 6 terms at this point if I've done it correctly. So now I need to combine some like terms. I only have one that's to the third, so I have just this term, this 10x to the third. When I look at to the second power, I've got this one and this one, so that would give me negative 2x to the second plus 5x to the second would be 3x to the second. When I do these, I've got positive 4x here and negative x there, so that'd be positive 3x. And then this is my only constant. And so I end up with this as my final simplified answer in standard form. But this is where I think it starts getting a little easier with those generic rectangles just to keep track of it all. So let's see this one that way. I generally choose to put the smaller one up and down and the longer one back and forth. That is a style thing. It has to do with what fits well on a piece of paper. It's not required to do it that way. But I'm going to choose to put this one here along this side, and then choose to put this one up and down. So 5x squared minus x plus 2. And there's my generic rectangle, or my chart if you prefer to think of it as a chart. And I can once again take each of these and multiply it by the other. So I would have 5x squared times 2x in this spot, and that would be 10x cubed. And I would have 2x times negative x for negative 2x squared here. And I would have 2x times 2 for 4x right here. This circling business is so that you can see where I'm getting my numbers and not something you would necessarily do while doing this yourself. I'm trying to be very clear on how I'm using my tool and trying to make that very visible on the paper. So that's something you might not need to do yourself. I'm just trying to be clear on what I'm doing. 5x squared times 1 is going to be 5x squared. Negative x times 1 is going to be negative x. And 2 times 1 is going to be 2. So I got the same things as I did before, but here it's much easier to see that I got all 6 of them, whereas I could easily make a mistake and only get 5 of them here and not necessarily notice. And particularly if I had a 3 times 3, where I had both as trinomials, so I had 9, that's when I would really start needing a tool like this. And this would, again, come out to, I have 1 that's to the third, so I have 10x third. These two are both squared, so I'd have 3x squared. These two are both just linear terms, so I'd have 3x, and then there I'd have plus 2. So I get the same answer using either of these organizational strategies, and you might just choose flexibly based on the problem. I start whenever it's trinomials busting out my charts. You might make that decision at a different place. It just has to do with what works best for you in that specific problem.